Hello everyone! Welcome to this online course on building materials. I am the lecturer for this lesson, Lin Yan. In this lesson, we will study the common types and characteristics of masonry blocks together. The knowledge objectives of this lesson are to master the basic concepts and systematic classification of blocks, to be familiar with the raw materials and characteristics of various common blocks, and to understand the core technical indicators and quality grades of blocks. The ability objectives are to acquire the ability to inspect incoming blocks and evaluate their quality, and to master the standard sampling and retesting procedures. The quality objectives are to cultivate rigorous and meticulous engineering quality inspection literacy, to establish awareness of standardized procedures, and to strengthen quality and responsibility awareness. First, let us study the overview of blocks. Blocks are artificial masonry units used in construction, mostly in the shape of rectangular hexahedrons. Blocks are classified according to the following 4 points. Now let us learn about several common types. Autoclaved aerated concrete block. A porous silicate block made with siliceous and calcareous materials as main raw materials, mixed with gas-forming agents, stirred with water to form voids through chemical reaction, and produced through pouring, pre-curing, cutting, and autoclave curing processes. Fly ash small block. Small hollow blocks made by mixing fly ash, cement, various lightweight or heavy aggregates, and water as main components. The fly ash content shall not be less than 20% of the total raw material mass, and the cement content shall not be less than 10% of the total raw material mass. Ordinary concrete small hollow block. It's made with cement as binder, sand and stone as aggregates, through mixing, vibrating, or pressing, forming, and curing processes. The void ratio is 25% or more. They are commonly used in load-bearing parts. Composite insulated block. Blocks formed by combining load-bearing block wall materials, sintered or non-sintered, with thermal insulation materials to create blocks with obvious thermal insulation functions. Main types include sandwich composite insulated blocks, filled composite insulated blocks, and veneered composite insulated blocks. Next, let us study the technical indicators of common blocks. Specifications and dimensions of autoclaved aerated concrete blocks and specific dimensional deviation requirements are shown in the table. Blocks are divided into 7 strength grades: a 1.0, a 2.0, a 2.5, a 3.5, a 5.0, a 7.5, and a 10. According to dry density, they are divided into 6 grades: B03, B04, B05, B06, B07, and B08. Blocks are classified into 2 quality grades, Superior Product A and Qualified Product B, based on dimensional deviation in appearance quality, dry density, compressive strength, and frost resistance. Block product marking method. Example, for an autoclaved aerated concrete block with strength grade A 3.5, dry density grade B05, superior quality and dimensions 600 mm by 200 mm by 250 mm, the marking is ACB A 3.5 B05 600 by 200 by 258 GB 11968. Finally, let us study the quality inspection of blocks. Incoming inspection of blocks. Items to be inspected include 1. Dimensional deviation, 2. Appearance quality, 3. Cube compressive strength, 4. Dry density. Dimensional deviation and appearance requirements are shown in the table. Dimensional and appearance inspection methods. 1. Measuring tools: steel ruler, steel tape, depth vernier caliper with a minimum scale of 1 mm. Two-dimensional measurement. Measure length, height, and breadth at the ends of two corresponding faces, taking two measurements for each dimension. Figure 1. Take the maximum value if the measured value is greater than the nominal dimension. Take the minimum value if the measured value is smaller than the nominal dimension. 3. Missing edges in corners. Count the number visually. Measure the projected area dimensions in the length, width, and height directions of the damaged part. Figure 2. 4. Cracks. Count the number visually. Take the maximum projected dimension on the surface as the length, as shown in Figure 3. If a crack extends from one face to another, use the sum of the projected dimensions on both faces, B plus H or L plus H in Figure 3. 5. Plane curvature. Measure the maximum gap on the curved surface, Figure 4. 6. Bursting, sticking, and damage depth. Place a steel ruler flat on the block surface and measure the maximum depth perpendicular to the ruler using a depth vernier caliper. 7. Oil stains, surface looseness, and delamination on block surface. Visual inspection. Sampling and retesting of blocks. Sampling rule. For blocks of the same type, specification, and grade, 10,000 pieces constitute one batch. Any quantity less than 10,000 pieces is also regarded as one batch. Randomly select 50 blocks for dimensional deviation and appearance inspection. From the blocks that pass the appearance and dimensional deviation inspection, randomly select 6 blocks to make specimens and perform the following tests. Dry density, 3 groups, 9 blocks. Strength grade, 3 groups, 9 blocks. 1. If the total number of non-conforming blocks among the 50 inspected does not exceed 5, the batch is judged as conforming to the corresponding grade. If more than 5, the batch is judged as non-conforming. 2. The dry density grade is determined by the average value of the test results from 3 groups of dry density specimens. If it meets the requirements in Table 6.6, the batch is judged qualified. 3. The strength grade is determined according to Table 6.7 based on the test results of 3 groups of compressive strength specimens. When the relationship between strength and dry density grades meets the provisions of Table 6.7 and the average compressive strength of each single group among the 3 groups is greater than the minimum value specified for that strength grade in Table 6.7, the batch is judged as conforming to the corresponding grade. If one or more groups fail to meet the minimum value, the batch is judged as non-conforming. For if all inspected items, dimensional deviation, appearance quality, cube compressive strength, and dry density of the products meet the technical requirements of the corresponding grade during factory inspection, the products are judged as the corresponding grade. Otherwise, they are downgraded or judged as unqualified. In this lesson, we have studied the common types and characteristics of masonry blocks as well as block quality inspection. As a basic building material, the development history of blocks reflects the innovation and progress of China's construction industry. From traditional clay bricks to today's various new environmentally friendly and energy-saving blocks, the enrichment of varieties and optimization of performance embody the concepts of scientific and technological innovation and green development. Learning the characteristics and applications of different blocks is not only related to engineering quality, but also inspires us to think about how to select environmentally friendly and efficient materials, contributing to the construction of a resource-saving and environment-friendly society. This is the responsibility and mission that builders of the new era should have. That's all for today's lesson. Thanks for your attention. See you next time.